Last part of this lecture deals with eccentric loading, and this only when you have shear joints, not tension, not tensile joints. Usually bolts are distributed in a symmetric pattern. That means, let me give you an example here. If we have this group of bolts, now the centroid can easily be identified, and it will be at the center here with equal distance. So the bolts have equal distance from the centroid. If you don't have symmetric distribution, if you have random distribution of bolts, then you need to identify the centroid X and Y, the position of centroid, using area and coordinates of each bolt. Then eccentric loading will lead to two types of forces: primary force and secondary force. So if we have bolts like this, 1, 2, 3, 4, with a centroid here, and then force is applied at the end here. Now the line of action of the force doesn't go through centroid, which means we have eccentric loading. And that eccentric loading coming from the different load carried by each bolt. So the result of this load, which doesn't go through the centroid, the line of action doesn't intersect centroid, will give me primary load, which can be seen if you look here. This one is the primary load. Primary load is equal, distributed equally between all the bolts. So if you have 4 bolts and you have 40 kilonewton applied at the end, then 40 divided by 4 bolts, each bolt will carry 10 newton or 10 kilonewton. And around centroid we will have bending moment. So this load will lead to bending moment around centroid, M. And to calculate M, you need distance from centroid up to this end. So you need this distance. So M is load times distance. Secondary load is coming from this bending moment. We need load to resist this bending moment. So you see the direction here to ensure that we have reaction to the bending moment. So we have 90 degrees angle between the secondary load and the line connecting centroid to the center of the bolt, and the rotation is in the same direction for all the bolts. So each bolt will have primary load and secondary load, and this will give you total load for each bolt. So bolts will not carry the exact amount of load, or the same amount of load will not be the same, because let's look at bolt B, this one here, and bolt A. For bolt B we have primary load and secondary load, and total load will be in this direction, because if you take components for this secondary load, components will give you this component and this component. So you see the vertical components will add to each other and will give you more or increase the total. For bolt A, if you take components for secondary load, you'll get this component in horizontal and this component in vertical. That means we have less load in vertical direction because you need to subtract these two loads, primary and the component for secondary. This will reduce total load in bolt A. So bolt B will carry more load than bolt A. And this is how you calculate secondary load for each bolt. Okay, so this formula 857 is the secondary load for bolt N. So let's say bolt A. For bolt A, we need bending moment and we need distance for bolt A from centroid, and then distance square for all the bolts. When distance is the same, then this can also be reduced.